Okay. What I like to do is just kind of go over some more examples dealing with buffers and with acid-base titration. So our first example that we're going to do is, how to prepare a buffer. So it says how many moles of ammonium chloride must be added to 2 liters of 0.1 molar ammonia to form a buffer whose pH is 9. Alright, so for this one, what we're going to have to do is we're going to have to set up an equilibrium weak base reaction. So if you kind of remember from the acid base chapter, we're going to take ammonia plus water. So we can get ammonium plus hydroxide. Okay, and the reason why that we're going to do that is because the ammonium ion is going to, we're going to get that from the ammonium chloride. Could we set up an ice table for this one? Yeah, but we really don't need to. Now, if we kind of look at our formula, and we're looking at, since this is a weak base, our formula would look like this. Concentration of ammonium times concentration of hydroxide would be over the concentration of ammonia. Now, the base dissociation constant for ammonia, Kv, I believe it's 1.8 times 10 to the negative fifth. Let me kind of look in the book real quickly. Make sure that I am correct. Yes. Alright, so since it is so small, we don't really have to go through the ice table and everything. Now, kind of plug some things in. So 1.8 times 10 to the negative fifth is equal to, now we're trying to find information about the ammonium ion, so I'm going to keep that as our unknown. Hydroxide, well, we know that the pH is going to be 9. So if we can calculate out the pOH from there. 14 minus 9 gives us 5. Okay, and if we have the pOH, we can find the hydroxide ion concentration by taking the antilog of the pOH. So the hydroxide concentration is 1 times 10 to the negative fifth. Now we have our ammonia concentration as 0.1. So we can find our ammonium, concentration. Alright, so if we take 1.8 times 10 to the negative fifth times 0.1, that's all divided by 1.0 times 10 to the negative fifth. Our ammonium ion concentration is going to be 0.18 molar. Now, go from there for moles. If we look at the problem, it says that it add to 2 liters of our ammonia solution. So moles of ammonium, what we're going to do is take our concentration, so 0.18 moles per liter, and multiply that by our volume, 2 liters, so 0.18 times 2. We need to add in 0.36 moles. Okay, now would that possibly be, can we convert that to grams? Yes, if the ammonium chloride was in solid form. If it's in liquid form, we can figure that out as well. Now the last thing I want to show you with the chapter 17 deals with titration, acid-base titration. Titration is just a process that we do in the lab, that we take a known concentration solution and we react it with a concentration, an unknown concentrated solution with a particular volume, and we can calculate out what is the concentration of the unknown solution, or we can, if it's an acid base, we can find out what the pH is going to be. So that's what we're going to do with today, because since an acid base reaction is a neutralization reaction, and if we take an acid and react it with the base, we get salt and water. Now with the acid, we're going to get the hydrogen ion. Base, we're going to get the hydroxide ion. So hydrogen ion plus hydroxide is going to give us water. So now, in this problem, it says calculate the pH when 40 milliliters and 51 milliliters of 0.1 molar sodium hydroxide solution have been added to 50 milliliters of 0.1 molar HCl solution. So what we're going to do is we are going to set up an ice table problem for this. It's going to be easy because we're going to be using this reaction. The hydrogen ion plus hydroxide yields to water. Now we have two different volumes, so we're going to set up two ice tables. Okay, now since water is a liquid, we're going to negate it out, and we're going to look at the 49 milliliters first. And I might have to stop so I can get another piece of paper. Anyway, okay, so what we're going to do here is we're going to be looking at moles throughout this process. Okay, so we need to figure out how many moles we have of each thing. Well, in the first one, this one we are going with the 49 milliliters of sodium hydroxide. So if we take our concentration, 0.1 times our volume, 0.049, we have a number of 0.0049 moles. Now for the hydrogen, 0.1 times 0.05, we have 0.0051. And since they are neutralizing, they are going to be canceling one another out. So our change is going to be negative. Now, what number do we put in for the change? Well, we put in the smallest number. Okay, so the 0.0049. Okay, so we have no more hydroxides. But for the hydrogen ion, if we take 0.005 minus 0.0049, we have 0.0001 moles. Now, since we do have number of moles of hydrogen, we can figure out our concentration and figure out our pH. Now, we added in 49 milliliters of sodium hydroxide, and we have 50 milliliters of HCl. So that would give us 99 milliliters of solution. So we take our number of moles, 0.0001 moles over 0.099 liters. That will give us our hydrogen ion concentration. Okay, so 0.0001 divided by 0.099, we got a concentration of 0.00101. Okay, so now that we have our hydrogen ion concentration, negative log of our hydrogen ion concentration, negative log 0.0010, and I'm coming up with pH of 3. Okay, now let's try the other one setup, but we're going to use the 51 milliliters of sodium hydroxide. Once again, we can cancel out water. Hydrogen ion stays the same. 0.005 moles. Now, just make sure I'm thinking correctly. 0.1 times 0.051, 0.0051 moles. So our smallest number of moles is our hydrogen ion. So 0. So in this case, kind of coming up the same number, but different aspect. And to find out, since we have 51 mils plus 50 mils, we have 101 milliliters of solution this time around. And since we have extra hydroxide ion concentration would be 0.0001 moles over 0.101 liters. 1, 2, 3, 1 divided by 0.101. A concentration of 0.000990 molar. And that's our hydroxide ion concentration. So POH negative log 0.000990. Our POH comes out to be 3. So then the pH, 14 minus 3, comes out to be 1, or 11, excuse me. Alright, now what I'm going to be doing is I am going to be making a video over thermodynamics over the weekend, so you can kind of look at that and everything. If you would like to have Google Meet time next week before the exam, please let me know. Email me and let me know what time works out for you. And I will talk to you later. Thank you.